let's just move on further towards the second case, or we can say the important concept in which we have the algebraic identities. So let's just recall the algebraic identities, because they are definitely be of the great importance to do some of the questions in this particular chapter. So let us suppose if I'm just talking about the very first identity. So the very first identity is nothing but x plus y whole square. So whenever we have x plus y whole square, this is nothing but equal to x square plus 2xy plus y square. So it means that for any particular expression of the type x plus y whole square, we can expand it into the formation of x square plus 2xy plus y square. This is nothing but the very first algebraic identity. Now let's just talk about the second identity. Second identity is x minus y whole square, which is nothing but is equal to x square minus 2xy plus of y square. Now let's just talk about the third identity. This is nothing but x square minus y square. So whenever we have such an expression, that is x square minus y square, we can expand it into the formation of x minus y into x plus y. So we have a product of two terms, that is x minus y, x plus y. Now let's just talk about the fourth identity, which is nothing but x plus a into x plus b. So here a and b are nothing but the constant. So whenever we have x plus a, x plus b, we can expand it into the formation of x square plus a plus b of x plus of ab. You can see this is nothing but x square plus a plus b of x plus of ab. This is our fourth identity. Now let's just talk about the fifth identity. So the fifth identity is nothing but x plus y plus z whole square. So it means we have three terms in between the bracket and their whole square. So we can expand it as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So this is nothing but the identity number 5. So these 5 are really very important identities to do the further question. So let's just do some of the examples that are related with these identities. So let us suppose if I'm just taking the very first example, and the example number 1 says find the product of the very first expression or the term we have is x plus 3, x plus 3. So let's just sort it out. So first of all, we have to find the product of x plus 3 and x plus 3. So let us suppose if I'm just starting the answer of this one as we have x plus 3 into x plus 3. So it means that we can write it as nothing but x plus 3 whole square, obviously, because we know that its power is 1, its power is 1. So if the base is same, the power adds up with each other. So x plus 3 whole square we have. Now in order to find the product of this, we can able to apply the algebraic identity over here. So what is that algebraic identity? Let us suppose if I'm just writing it over here, that we already know about the algebraic identity, which says that x plus y whole square is x square plus 2xy plus y square. This is nothing but the algebraic identity that we already know. Now we have to find out the product of x plus 3 whole square. So how we can find it? So first of all, you can see over here that if I'll compare this algebraic identity with this x plus 3 whole square, it means that in place of this y, we have this 3. So it means that in this algebraic identity, I just have to plug in the value y is equal to 3. Y is equal to 3 in this particular algebraic identity. So let's just plug in y is equal to 3 in this one. So if I'll just substitute y is equal to 3 in this algebraic identity, I'm just getting the answer as x plus 3 whole square is equal to x square will remain the same, and in place of y, I'm just taking 3 plus y means 3 whole square. So if I'm just taking the square, so it would be x square plus 3 into 2 is 6x plus of 3 square is nothing but 9. So it means that using this algebraic identity, I'm getting the answer or the product of x plus 3 whole square as nothing but x square plus 6x plus of 9, and this is nothing but my answer, which is nothing but the product of x plus 3 into x plus 3 using the algebraic identity x plus y whole square, which is equal to x square plus 2xy plus y square. Now in the same sense, let us suppose if I'm just moving on further with the second part, which says find the product of x minus 3 x plus 5. So now we have to find out the product of x minus 3 x plus 5. So first of all, let us suppose if I'm just talking about talking about this particular expression. So as you can see, if I'm just answering this one, so we can write x minus 3 into x plus 5 as nothing but x plus minus 3 and x plus 5. So I am just actually writing x minus 3 into the formation of x plus minus 3. Why am I just writing this particular term as this? Because we know that we already know about an algebraic identity. Let us suppose if I'm just writing it over here, we already know about an algebraic identity which is actually of the form x plus a into x plus b, which says it is equal to x square plus a plus b of x plus of ab. We already are aware about this algebraic identity, and we know that in this algebraic identity we have only one sign in between the two terms, that is nothing but plus, so it would be convenient for us if I'll convert this negative sign into the positive one, so that it would be easy for me to plug in all the values over here. So that's why I have converted minus 3 into plus minus 3. So if I'll just compare this particular expression with this one, so I can easily say that a is nothing but is equal to minus of 3 and b is nothing but is equal to 5. So by comparison I can say over here that a is nothing but minus of 3 and b is nothing but is equal to 5. So it means that we have to plug in all the values of a is equal to minus 3 and b is equal to 5 in this particular algebraic identity. So let's just plug in all the values over here. So this would be x plus minus 3 and x plus 5, which is equal to x square would remain the same plus a. In place of a we have to use minus 3, in place of b we have to use 5, x would remain as it is, a is minus 3, b is 5. So this would be nothing but x square plus of 2 of x plus minus of 15, and further it is x square plus of 2 of x minus of 15. So at the end what we are getting the product of x plus minus 3, x plus 5 as nothing but is equal to x square plus 2x minus 15, which is nothing but the answer or the product of this particular second part. So this is all about the example which is related with some of the algebraic identities.